NASA's Juno spacecraft captured an intriguing sight during its close flyby of Jupiter's icy moon Europa in September 2022. What it saw was a giant creature beneath its icy surface. As Juno approached Europa at an altitude of just 355 kilometers, 220 miles, its high-resolution cameras and instruments revealed a chaotic terrain unlike anything seen before. Amidst the labyrinth of ridges, grooves, and dark stains that crisscross the moon's surface, a distinct feature stood out, measuring a staggering 42 miles, 67 kilometers, at its broadest point. It appeared to be a relatively young formation, with prominent ridges encircling it and crumbling into the pronounced feature. The surrounding ridge formations suggested that Europa's icy mantle might be yielding in areas where pockets of briny water from the subsurface ocean lurked beneath the surface. These findings were recently published in the Journal of Geophysical Research, Planets. A team of scientists who has been painstakingly analyzing Juno's data since 2022 at the Jet Propulsion Laboratory, California Institute of Technology made this observation. "When we first saw the images, we couldn't believe our eyes," exclaimed Dr. Emily Lakdawala, a planetary scientist at the Jet Propulsion Laboratory. "The platypus looked like nothing we'd ever seen on Europa before. It was a tangled mess of ice and ridges, almost as if the surface was being churned from below." As the Juno team analyzed the data, they made a startling realization. The platypus appeared to be moving and shifting across Europa's surface. The ridges and ice blocks within the feature seemed to be rearranging themselves, indicating that the icy crust was not as static as previously thought. These features suggest present-day surface activity and the presence of subsurface liquid water on Europa, said Heidi Becker, lead co-investigator for Juno's Stellar Reference Unit, SRU, at NASA's Jet Propulsion Laboratory. "The platypus is one of Europa's youngest features, and it's actively changing before our eyes." To confirm their suspicions, the team compared the Juno images with previous observations of the same region from the Galileo mission in the late 1990s. The differences were striking. The platypus had shifted and rearranged itself significantly over the past 2 decades. "It's like watching a time-lapse of Europa's surface," remarked Dr. Robert Pappalardo, a planetary scientist at NASA's Jet Propulsion Laboratory. "The icy crust is slowly but surely being reshaped, likely by the forces exerted by the subsurface ocean below." The discovery of the shifting platypus added weight to the theory that Europa's icy shell is decoupled from its rocky interior, a phenomenon known as true polar wander. This decoupling leads to high stress levels and predictable fracture patterns, causing the icy crust to shift and rearrange itself over time. The presence of a subsurface ocean on Europa has long been a tantalizing prospect for astrobiologists searching for potential habitats for life beyond Earth. The discovery of the shifting platypus and the evidence of briny pockets beneath the surface only added to the intrigue. If the icy crust is indeed yielding in areas where liquid water lurks beneath, it could provide a pathway for nutrients and chemical energy to reach the subsurface ocean, potentially fueling any microbial life that might exist there. "Europa's subsurface ocean could be a veritable oasis for life," said Dr. Brittany Schmidt, a planetary scientist at Georgia Tech. "The shifting platypus suggests that there's a constant exchange of materials between the surface and the ocean below, which could provide the necessary ingredients for life to thrive. Moreover, the tidal flexing caused by Europa's orbit around Jupiter is believed to generate enough heat to maintain the liquid ocean beneath the surface, providing a potential energy source for any hypothetical life forms." As NASA's Europa Clipper mission and the European Space Agency's JUICE mission prepare to explore Europa in greater detail, the shifting platypus will undoubtedly be a prime target for investigation, offering insights into the moon's dynamic geology and the potential for life in its subsurface ocean. "The platypus is a game-changer," said Dr. Lakdawala. "It's a reminder that Europa is a living, breathing world, and that the search for life beyond Earth is more exciting than ever before." With the tantalizing evidence of the shifting platypus, scientists around the world eagerly awaited the arrival of the Europa Clipper and JUICE missions. These dedicated spacecraft would be equipped with advanced instruments and sensors, capable of studying Europa's surface and subsurface in unprecedented detail. One of the key objectives would be to determine the composition and depth of the subsurface ocean, as well as its potential for habitability. Instruments like ice-penetrating radar and spectrometers would be used to probe beneath the icy crust, searching for signs of liquid water and organic compounds. If we can confirm the presence of liquid water and the right chemical ingredients, it would be a major step towards understanding the potential for life on Europa, said Dr. Schmidt. And who knows, we might even find evidence of actual life forms lurking beneath the surface. The shifting platypus would also be a prime target for detailed mapping and analysis, as scientists sought to understand the mechanisms driving its movement and the implications for Europa's overall geology. The platypus is like a window into Europa's interior, said Dr. Pappalardo. By studying how it shifts and changes over time, we can gain insights into the forces at play beneath the surface, and perhaps even glimpse the dynamics of the subsurface ocean itself. As the missions progressed, the data and observations would be scrutinized by teams of scientists around the world, each piece of evidence bringing humanity closer to unraveling the mysteries of Europa and the potential for life beyond our own planet. It's a reminder that even in our own cosmic backyard, there are still wonders waiting to be discovered. NASA is fond of inventing unique acronyms, and the peculiar feature on the surface that appeared to be shifting and moving, earning it the nickname Platypus due to its bizarre shape, was a jumbled mass of ice blocks, ridges, and reddish-brown material. As NASA's Europa Clipper mission and the European Space Agency's JUICE mission prepare to explore Europa in greater detail, the shifting platypus will undoubtedly be a prime target for investigation, offering insights into the Moon's dynamic geology and the potential for life in its subsurface ocean. If you like the video, please like and subscribe, as it will truly make a difference for this channel.